strong OOP programming language that everything should relate it to an object, like every method, every data member should relate it to a class or a instance. But Java still want to provide something that's similar to the functional programming. So they further introduce the functional interface. But actually, functional interface is just something similar to functional programming style, but it's still OOP things. Like functional interface is still, you have to rely on an object. But this object will only have like one abstract method. So this make it something like a functional programming. Like in Python, you just define a method and use that method. But here you just define an object that with one single abstract method. So you just give concrete implement for that abstract method. So make it similar to functional programming, but still there is an object here. You have to invoke the method through that object. So yeah, so it's still OOP, but just similar to functional programming. So the definition for functional interface is that this interface only contains one abstract method, right? So only contains one abstract method. So when we say that only contains one abstract method, that means this functional interface can still have other method. Like it does not mean it can only contains one method. It means it can only contains one abstract method. So you can still have some like default or static method for this interface. Remember that those methods are not abstract in the interface, right? When you define a default or static method, like the examples I gave in the day one, you have to, maybe here, you have to give the implementation for the method. So it does not affect that the definition that we only have one abstract method. And so let me think. Oh, one thing is that when you try to define a functional interface, is this like annotation to be required? Let me think. It should be add functional interface, right? So when you want to customize your own functional interface, is this like annotation to be required? Does anyone know? Any answer to this? Yeah, it's recommended. This is for Lambda. No, this is not related to the Lambda expression, but this functional interface, right, is recommended, but not mandatory. Like if you do not use this annotation and you define like an interface, functional like interface, maybe just randomly name it. If you just provided one abstract method, like one abstract task method, it's still to be a functional interface. And just the annotation, just using the like the reflection mechanism that for the GVM, like when it the GVM radio code, like it will, when it read the annotation there, it will check whether there is only one abstract method in your interface. And if like you provided this annotation and when the compiler read your code, if you have multiple abstract method, for example, oh, this abstract is no more needed. Like we have another test too. It should give you an error because you provided this annotation. It will check your code that if there is multiple abstract method in your functional interface. But if you remove it, it won't check for you. Everything just function like a normal interface, but here it's not a functional interface. So, and in some of the in some version, like maybe the compiler or the GVM, the annotation will be mandatory, but it depends on the implementations. But it suggests that you just provided this annotation to avoid any possible errors. So and so this is functional interface. And do you know any functional interface, like, or have you ever used any functional interface in while you are coding? Any answer? Like, do you know any functional interface? Any type of functional interfaces? Yeah, yeah, cool. Runnable. Yeah, we use that in the like in week one's multi-threading part, right? We use runnable to provide the task for the threads. And any other things like the runnable? So when you talk about runnable, there is another thing, another functional interface that's very similar to, yeah, comparator is also another good answer. Like when you use the tree map, yeah, callable, perfect. So for the comparator that you used when you trying to use the like the priority queue, or you're trying to use the sort method, or you're trying to use the tree map, there is a like a sorting order. So you have to provide a comparator for your collector to compare two elements, to objects. And also, when you talk about runnable, you should never forget about the callable, right? These two interface, functional interface, always compared together. Like there are plenty of um, uh, like the interview questions that ask you the difference between runnable and callable. We can just directly maybe we can just directly oh, sorry, it should not be public, because one file can only contains one public class. So what I want to do here, I want to just create two object that's created from this two functional interface tab. Like one is implement the runnable interface, one implement the callable interface. So here we can create a runnable new one. And so remember, this is a anonymous class, right? A class without name. So this is why it's called anonymous. And we will instantiate the object from the anonymous class, not from the interface. So remember, interface can never be instantiated from, right? So you see, there is one abstract method called run. And this is the abstract method that we need to implement for this runnable interface. And you see the method signature, it is a void method, means it does not return anything. And also it does not take any input parameters. So it does not take anything, it does not return anything. It just run some logic defined in the run method. So this is why it called run. It does not apply something, or it does not supply anything. So it does not take anything, it does not output anything. So it's called a runnable. And also there's one thing called callable. So what does callable do? You can create a new callable object. You can check that callable functional interface have a call method in the interface. So you see this this functional interface will return an object. So this return type you can define by using the generic, like here. You can, if you specify that your return type should be integer, then inside your call method, this this one should also be like right to integer. Is a method has no real code in it? Is it the abstract method? No, no, no. It depends on if it is whether it is a abstract method does not depends on like whether there is a code or not in the method body. It is that whether there is a method body or not, or and also the keywords that you provide here, like the abstract. But remember that for the interface, it just implicitly provides you the keywords abstract, right? So you see this interface, like if you just provide the abstract or test, it will tells you that the abstract is redundant because it implicitly provides you this public abstract keywords. So here you see if it is an abstract method, it does not have the method body, it does not have this curly bracket, right? So you see this one is not an abstract method because it has the method body, this curly bracket, but I just did not write anything in it. So, and also if you're confused with the interface, I can give you an example for like abstract class. So this abstract class, you see, because abstract class can contains either abstract method or normal method. So in here, the abstract does not provide to you implicitly. So for example, if I have a void test method, if you just write something like that, it will give you an error like missing method body or declared abstract. So either if you provide a curly bracket here, make it not it will become a concrete method, not an abstract method, or you want to define an abstract method here, you have to explicitly give the abstract keywords. So then it will become an abstract method. So yep. And so here we want to override. So let's resume to the callable. So for callable, we see callable will return an object. So when you submit it into your executors, like the thread pools, or provide it to like just to provide it as a task to your thread pool, then it will return you something, and this thing you can wrap it in the future object, right? The future object is used with your thread pool as a wrapper class that can wrap the return type of your task. So and also you should see that the callable, this call method also can throw exception, right? So that means if something wrong happened here, or you will like voluntarily throw some exception here. Like this, then this return statement will never be reached. Maybe it's a bad example. Maybe just doing something like in the x equals to 1 divided by 0, so it should throw you an exception, but because the callable have the throws method, so it will throw the method to your like if you wrap it in the future object, the exception will be this exception will be handled by the future object. Like, let me give you example. Like, for example, if I have a maybe create a new class, or just this class. If I have maybe just some executor surveys, executors, should be no new keywords. Executors dot new, maybe just pick a fixed or a single thread pool. New single thread pool. but I do not want to define the thread pool by myself. So I can do one thing that I can submit. You see the submit method is a overloaded method, so you can submit a callable to it. So here we can just submit this callable that defined here into our, oh, it should be static. So I'm not sure whether I can just make this callable object to be static. Oh, and we will need a future object to future should, like, this callable is returning an integer, right? So here we will wrap an integer object and future like this. And later we can just system out our future dot get. So remember, this get method is is a blocking method, which means when you run the get method in your main thread, like in the main method is running on the main thread, right? We're calling the get method. It will block the main method to wait for this worker thread in the thread pool to finish its job, and then when it get the result, then you can resume your main thread. So this is called a block method. So this get will block your main thread until the worker thread finish its task, like this. In here is the callable finish task. Callable is an interface. How are you able to create an instance of it? So yeah, this is what I explained, that we can never, like I emphasize this for several times, that we can never instantiate directly from an interface. So this is called an anonymous class. So this anonymous class, the syntax is to create an anonymous class that implements our callable interface. So actually, we are instantiate an instance from the anonymous class who implements this callable interface. So actually here we are defining the method in the anonymous class, that this anonymous class is implementing this callable interface. So in the anonymous class, we are trying to override this abstract method that in the callable interface, right? And later an interface will be instantiated from this anonymous class. So this is how we create an instance from it. And also this is called an upcasting, right? It's part of the polymorphism. Like, because this anonymous class is implements the callable interface, just like the linked list implement the list interface. So when you create it and instantiate an object, instantiate an instance from this anonymous class, this object can be assigned to the reference variable that of callable type, right? This is like something of upcasting, just like the linked list and the relationship between the linked list and the list, right? You created a linked list object, but assigned to a reference variable of list type. So here you created an callable, not callable, like anonymous class instance, and who implement the callable interface and assign it to the reference variable. So let's go back. So here, system out the future.get, and then you see it asks us to handle the checked exception. So here we have to throw exception. And when we run it, it should throw an exception, like divided by 0, right? Arithmetic exception, right? Divided by 0. So you see the exception is thrown here. And if you come out this, just return some maybe 10 or 100, we run it again, because this yeah, because this like callable return a 100, and it will wrap in your future object. Later when you use the future.get, you can get the object. And also, if you do not provide us, even though there is a arithmetic exception, you cannot get it, because the exception is inside the future object. Only when you use the get, you can get the exception out from it. Yes, this is the this is the callable. And let me think. So let us draw a conclusion that so here, because I think I want to give something like another example, like because this provide us the throws keywords, right? So we should be able to, but because there is, if I just directly throw an exception, does not allow me to write this return statement. So if I do something like throw exception, let me try. And I comment out this, it allows me to run it. Yeah, it allows me to run. So like because this throws keywords, right? It allows you to like throw some checked exception when you compile your code. But you remember that this is one way that we handle the check exception. The compiler, when the compiler forces us to handle like how we want to handle the exception, we can use the throws or tries. But you see, this run does not provide the throws keyword. So if you're doing something similar here, you're trying to throw a new exception here, it should give you like unhandled exception, right? Because if you cannot do something like this, because the method signature does not, the method signature in the runnable interface does not provide the throw keywords for you. So when you override it, you cannot do that. You see, the run in anonymous class derived from the runnable class with run in runnable like overrated method does not throw exception, because the original method signature does not have the throws. So you cannot do something like this, but it's callable. It provides you the throws keywords. So you are afraid to throw a checked exception here. So this is one difference between the runnable and callable. Like here, runnable first, it just have a run method, and callable have a call method, and runnable does not return anything, right? And callable, let me think how to make it. Maybe I should move this compared to a new place, like here, because this is quite important. Many interview questions will ask you about the difference between runnable and callable. If you do not use future.get to retrieve the exception, will main thread block? No, it will not. Like if you do not even call the get method in the main thread, then this main thread just run as it just run itself, like run it individually. Like if you system out something here in the main, so you see, even though you submit a task, or you can even write a for loop to constantly, I think, all right, this here, I have to maybe just like you wish to throw exception, right? And so here the callable will throw exception, and you see the main method just run separately because it's multi-threading, right? So the worker thread should not interfere with the main thread until unless you provide some block method like join, something we've seen like the join, right? And also here is the future.get. Those method, when you invoke it in your main thread, in your main method, it will block your main method to wait for the worker thread. But here, if you do not call the get method, then these two thread, they just run in parallel, so they won't interfere with each other. Why the code is still running? That is because you remember that the one usage of the thread pool is to reuse the thread, right? So so when I submit the task, even though the task is over, we want to reuse our code, so our thread pool is still running, right? So the code is still running. So you see, if you want to stop your thread pool, you can call something like shutdown. And then when you run it again, it should run it again. It just exists because you shut down your thread pool when all the things like finished. Okay, no problem. Yep, and but the reason we want to use the thread pool is that we want to keep the thread alive, and we can constantly providing new tasks to the thread pool, right? This is the reason we use this thread pool. And let me draw a conclusion for the difference between runnable and callable because it's quite important. So runnable, you have a run method, and callable have a call method. And runnable cannot return anything, and callable can return an object. Also, runnable cannot do not have a throws, so that means you cannot handle checked exception. That doesn't mean that runnable cannot throw exception, right? So suppose you run some, because I think the previous arithmetic exception I give is not a good example because that is a runtime exception. Runnable just means it does not handle the checked exception, but if you have some like unchecked exception, maybe like return, no, not return, just one index equals to 1 divided by 0. So this is unchecked exception. So the runnable still similar here, like, but if you want to submit, let me come out of this. I remember if you have to provide a void here for the future because the runnable does not return anything, so you should provide the void to your future. But let me see if I can make it. I never tried this. So, oh, still static, I guess. And what does it tell us? Provided future, required type future void, return, maybe just to use the wild card. Yeah. So use the wild card, that means whatever type you return to me, I will just accept it. So here, like, if you run just in this way, it does not returns you anything, just because we do not get exception from the future, right? So here we can use, we do not even to system out print out it because we just call the future.get. It should just get the exception directly. Yep. So also, so that means you have to be cautious that no throws keywords does not means that it does not throws any, just means it cannot handle the checked exception. So remember that this keywords you use to resolve the checked exception, right? So for example, if you have some something like the class for name method, remember that we used previously, like the class for name, and you provide a like the week 2, day 5. You cannot, if you want to write here, you just you need the try block. You cannot use the throws, but if you write it in here, it's all good because you already have the throws keyword, right? So that means without the throws keywords, runnable cannot handle the check exception, but it still can throw a unchecked exception happened in your runtime, right? Because whatever that unexpected happened in your runtime, you still should throws it. You cannot just omit it. So for the callable, it provide throws keywords, so you can handle the checked exception. So those are the significant, like most significant differences between the runnable and callable functional interface. And also you mentioned about the comparator. So like we can have a comparator to check what inside a comparator, right? Oh no, not comparable. So remember that comparable is one interface that you want to implement for your object. Like if you do not implement an object for your, if you define a class that you do not inherit from the implement this comparable interface, like comparable interface, then you see the name infers everything, like it's comparable. So that means if it is if it implement the comparable interface, then that means this object is comparable, which means if you do not implement the comparable, means this object is not comparable, means you cannot compare to object directly, like because this comparable interface provides you a method called compare to, right? So string is a comparable. So you can, when you try to compare to string, one way is that, for example, if you have two string, you want to compare it by the lexical of order, you can just like the string 1 equals to C, or string S2 equals to BCA, or just random name it, because the string is comparable, right? So it implements the comparable interface. So it gives you a compare to method. So you can compare this to string. So, but comparable is not a functional interface. Maybe if I like introduce this thing here, will be a kind of misunderstanding you guys. So I think I just because sometimes some people just confused with comparable and comparator. So you see the comparable is like a feature, like a property of your object. So if your object is a comparable, then that means it has the feature, it has the ability to compare to another object, like the same type object. But comparator, just the name infers, is a tool, is a comparator tool. So you can use this tool to compare two object. So comparator is the functional interface. So when you try to like define a comparable here, like let's just check. You see the comparable, there is a why is still sorry for the typo. I was meant to create a comparator, like new comparator. So the comparator, this comparator is a functional interface. Remember that comparable is not functional interface. Comparator is functional interface. So this functional interface is like provide you a tool to compare to object. So you see, you should like this object type, you have to you can use generic to do something like this. You see, this is generic type. Like when you define your comparator, you can for the type safe reason, you can use the generic to provide the interface type. Yeah, not integer type, and then your compare method should only take the integer. And you see, if it do not, it will gives you like error. So I have to make it integer and integer, and then let me see. Method does not override method from its superclass. Why was it? I think the reason is I should also provide integer here, I guess. Yeah, so this resolved the problem. Like you provide integer here, that means you restrict your type to only be integer. If it did not provide it, just object type. This is comparator. So you will use this a lot in your when you're doing the lead code question, right? Like when you're trying to maybe compute the case frequency, maybe you will use the priority queue, right? So you have to provide a comparator to your priority queue. Otherwise, the priority queue will be just from when you ever. So priority queue is a heap, right? So it will be default to be a main heap. Like whenever you pull an element from your priority queue, if you do not provide the comparator, it will just pull the smallest element from the priority queue. But you can change the behavior by providing a comparator. So it can make your priority queue to be a max heap, and then it can return the most largest element in the priority queue. And also we still have other types of functional. Can we write this into Lambda expression? Yeah, sure, because I think if I directly write it into Lambda expression, it will confuse you guys. So I just want to introduce the Lambda expression later. So because also this when we like switch the implementation from the anonymous class to Lambda expression, it will make it more clear that why we need the Lambda expression, that to make the code neat and also save a lot of code. So, but here, let me just give further more commonly seen functional interface. So later, we will use those functional interface in our Stream API. So like we can still have something called supplier. So this is the functional interface, as the name infers. It supplies an object to you. Like you have a supplier. Supplier here. This new supplier. You see, supplier have a get method, and it does not throw, does not check for handle for the unchecked exception, checked exception, and also, but it does not take any input parameters, but it will return an object. So also you can define the return type in when you define it. Like if you provide a generic type here, it will just like the comparator or the runnable or the like the callable, it will restrict the return type to a specific object type, not here just the object type. So this is the supplier. So later we will use this functional interface in our like Stream API. And also remember that the functional interface, the reason is that we're trying to provide a way similar to functional programming. So but still, because Java is the OOP programming language, so if you're trying to invoke the method of this get, you still have to doing something like make it static first. Static like supplier dot get, doing something like this. It will return the object to you. This is functional interface. Other type, like still we got something like consumer. Consumer have a accept method. It will, let's see. Consumer. It has an accept method. It does not return anything. It will consume the input you give to it. So this is consumer. And also we can have functional interface. So the functional interface, it will take one thing, take one object as input and also return one object as the output. So it has a, maybe let's just save some time. Let me just write that method. So it will take an object, and also it will return the function. It will return an object to you. Take an object and return an object. This is called functional interface. Also, we have the by function functional interface. That means you will take two inputs in your interface, like the by function functional interface. It will take two inputs. So that is why it's called by. And also we have something like the, we'll use it a lot in the Stream API that called predicate. So this function interface have a Boolean return type and test method. It will take an object and return a Boolean type. So here, if most of the usage is that you use it with the filter stream method that of the Stream API. So when you use the filter, you have to provide the predicate functional interface. So it will use the task method to examine whether the like the stream object is should be true or false, and then filter it. Like if it is false, then you will just get rid of that element in the string. So this is predicate, and also there will be like a lot of functional interface outside there, and if you have interest, you can go over those things. But knowing like roundable, callable, comparator, and the things, supplier predicate, those things is quite enough for the interview questions. Like when they ask you about what is function interface, explain the definition and then give some examples how to use them, things like that. So this is functional interface. And does anyone good with this part, like the functional interface? So if all good, we can go to the next part, Lambda expression. So Lambda expression is like the most, the syntax is like you can write something like directly, like something like this, this parenthesis, or you can, if you only have one input, you can even get rid of the parenthesis. But this parenthesis is for wrapping the input element. And this, on the right side of your arrow, you can either provide a curly bracket, but if you provide a curly bracket and then that means you have to write something like a method. Like if you want to return something, you have to write return, maybe return 10 or something like this. But if you just have one line of code and you try to return something, you can just get rid of the curly bracket and write something like this, just 10. So it will return the 10. So for example, test you have you want to use the lambda expression, and remember that the lambda expression can only be used with this is a syntax for the lambda expression, and remember that the lambda expression can only be used with the functional interface. Why was it? Because all in all, the lambda expression is used to provide an implementation for a method, right? So if you have a duplicate, if you have multiple abstract method in your abstract class or in your interface, let's say, so then when you give a lambda expression to that functional interface type reference variable, then it will be ambiguous, right? If you have multiple abstract methods, then how will the compiler know that which method that is this lambda expression implemented? So this is why the lambda expression can only work with the functional interface, because the functional interface only contains one abstract method. So there's no ambiguous, right? We just use this lambda expression to give implementation for that, to give to that specific only one abstract method. So here we can write something like, remember the supplier only does not take anything but return one thing. So we can define a supplier here, and here we no more need the no more write the anonymous class like those tedious code. We just doing something like remember supplier does not take anything, and you can just write something like this. So if you only have one line of the code, it will implicitly like have the return for you. So this 10 will be returned to the will be just the return object of this get method. So it will return 10, and it will be as the return object. So here you define the supplier, and then let's see if we call the supplier the get method, invoke the get method that we defined. So you see this is the get method that we use the lambda expression to give the concrete implementation here, and then we invoke this method. So it should give us a 10, right? You see, it gives us a 10. And also this supplier can do much more things, like when you work with the Stream API, maybe sometimes you want to supply a hash map. You see, when you get, it will returns you a hash map. You see, there's a hash map. You can maybe we cannot directly call the dog class. Should something like get class. Run it. You see, class hash map. So this is lambda expression, and if you do not feel comfortable with this way, you can just use the curly bracket and return 10 or something like this. So if you write the curly bracket, then when you want to return something, this you have to write the return keywords. And let me try another thing, like the most commonly used comparator. And maybe we want to compare two integer, and here we can do something like, so the comparator means you have to compare two integer object, right? So to integer instance, right? So you have to take x1 and x2 as the input, and then you compare them. So here, what we can do is we can write some logic like return x1 minus x2, things like this. So this is the ascending order when you provide it to the priority queue or sorting algorithm, right? And if you want to do the descending order, you can do something like this. And, for example, if I have a list of integer randomly list of integer like recess list. We have maybe 1 to randomly like 10 or 6, something like this. You want to use the collect, not collectors, should be collections, I remember. Collections or sorts, sort your list. And you provide your comparator, right? After this, when you system out this list again, you should see a descending order because we use x2 minus x1, and if you want to provide the ascending order, you just something like this. You see, it's ascending order now. And if you want to make in this way, it will be more clear that what happens here. So, but most of the case, maybe when you are familiar with this, you just directly provide the function, provide the lambda expression here. You do not have to define a comparator reference variable and then provide the reference variable here. Right? It just directly just directly write something like this. This will be sufficient. You can comment out this thing to make sure that they are not useful. So here you just write something like this. And why it is being grayed out, that is because by default, the sort algorithm is using the ascending order. So right, so you are writing some code that use this, but if you change it, that you say, hey, I do not want ascending order, I want to descending order. So you can do something like this. Right here. And so this logic can be a little bit more. So when you want to sort your, for example, let's say you want to sort the string and maybe sort the string based on their, let's say you have a list of string and string has a list of string of, maybe there is a duplicate strings, and also you want to sort the list of string by their frequency. So if the string has a higher frequency, then it should be placed like more than once in the list, like in the first of the list, if it has a higher frequency, and just if it has a less frequency, it will be placed at the right, like sort by the frequency. And what if they have like the same frequency, then you want to sort it by the lexicographical order. So in that way you can, but if we want to do something like this, maybe, but I think it will waste some time of this. Just to give an idea. So how to use this comparator. So like you have a list of string list. Restore this list, maybe ABC, as you have a ABC, and but I think this is not a good example, like, because for in this case you have to even count the frequency. Maybe let me introduce this in the Stream API, like, because I want to use the Stream API to maybe count the frequency into a hash map and later do some operations on that. In that way, we can like give an example, like how to use the Lambda expression and explain the usage of the Lambda expression. But for now, let's just skip it to the optional because we only have limited time for this. And let's just save this example maybe in the stream API things. So, but what I want to do here is just count the frequency and then sort, just something like that. So, but it's nothing complicated. Just maybe just forgot it here. So this is the Lambda expression. So just used to give a implementation for to replace this anonymous class, right? So whenever you use this Lambda expression, it will function just like an anonymous class, and one object will be instantiated from that anonymous class who implement your run functional interface. Just like I remember in the day one, I have write those the rules of how does the Lambda expression worked. Let me see if I can find it. If no, okay, I cannot find it. But the idea is just use the Lambda expression to replace your anonymous class. So in this way, you can use the Lambda expression to implement the method that is to create a anonymous class and then instantiate an object from that anonymous class. So something similar, but just using the Lambda expression to save some code. So just remember that this line of code actually provides you an object, right? So although it just looks like a function, but actually it provide an instance with a implemented method. Right? So this is functional interface. So far, any questions related to the Lambda expression and functional interface? So if no questions, then I think we can move to the next things called optional. Any questions? Like if you are confused with the Lambda expression or confused with the functional interface, you can feel free to ask me. Okay, so if no questions, let's just take 10 minutes break and let's come back at 11:10.